Much, Alex. That was a great talk. We are on to the last session, and this is our first online session for Delta, coming all the way from Belfast in Northern Ireland. I'd like to introduce Jonathan Cole, who's going to talk about learning beliefs of first-year students. So, Jonathan, over to you. Good morning to you, and good afternoon from here.
Good afternoon, Michael. Is it Michael I'm speaking to?
We can't hear you.
How about that?
Ash, you can hear, but we can't. Just hang on a sec. Do you want to try now, Jonathan?
Yes. How is that now?
No, just hang on a sec, please. Try again now, Jonathan, please.
Hello?
Yep, beautiful.
Good. Well, good afternoon, everyone, and thank you very much for inviting me. It's good to be part of the Delta for the first time, and going to talk about mathematical learning beliefs. Just trying to move on my slides. Oh, that's it now. Yes, the Delta for me is 10 hours. This morning here, it's just after 7 a.m. Speaking to you from home just north of Belfast this morning. And there are just a few photographs from Northern Ireland. As we start off, you might have heard of the Giant's Causeway there in the top left, and also the shipyard in Belfast where the Titanic was built. But today's talk is about learning beliefs. I've been lecturing here in Queen's University, Belfast for just over 20 years, largely to engineering students, first and second year, undergraduates, generally large classes as well. And of course, things have varied quite a bit over that time, but for the last 8 or so years, I've been working with this sort of a model for the first years. The maths is a core module, and it runs throughout the academic year, the 26 weeks. They have to pass maths to get into second year of the engineering degree. And we'd have typically 150 to 200 students in the class. So we've got a final exam and a mid-year class test, and then a continuous assessment based on a weekly worksheet there over around 20 of the weeks in the year. So we've been trying to introduce this aspect here, peer review and self-assessment and reflection as part of the module in order to develop these skills. And 40% of the module mark comes from a reflective piece, and the other 60% from the exam and test. And they have to pass the two parts individually because the learning outcomes are so different. But in terms of the learning beliefs, here's some of the literature that I've been basing this work on. It's been going on for quite a while there. This the notion of students' beliefs is that they influence their learning behaviour, and they seem to influence achievement as well, certainly at secondary level. Mathematical resilience involves a collection of beliefs that can be divided into various categories here. I'm using the model reference. Sue Johnston Wilder has done a lot of work in this area. So a growth theory of learning refers to the belief that people can improve their mathematical abilities through application and instruction. And having a growth mindset should facilitate perseverance when confronted with challenges. Struggle refers to the belief that sometimes much effort is required because maths can be a challenge to learn, not because of personal limitations. So, in theory, students who understand that struggling with mathematics is not unusual should have more tolerance in the face of difficulties. Value refers to the extent to which students find studying mathematics important in achieving their goals. And if the students value the learning and achievement associated with the subject, they should be more willing to engage actively with it in theory. So, given this connection then between beliefs and behaviour and potentially achievement, it's of interest to investigate the students' beliefs as they begin their studies and even as they progress through them. So I've proposed the following research questions. What beliefs do the students hold about learning mathematics? How do their beliefs change over the first year of their degree? And have we noticed any change in recent years before and since the COVID pandemic? So the research instrument was a questionnaire, and it contains sections with items here developed from the literature. So these items are related to beliefs about value there, the use of mathematics, whether the mathematics will help understanding other topics, and whether good thinking skills will be developed. And then some items related to struggle there. Everyone makes mathematics, for example, whether they believe struggle is normal in working on maths. The items here based on growth. So this is to do with the growth mindset, whether people are either good at maths, whether they can develop their mathematical skills or not. And then we've a section on confidence. Here, 6 items to do with confidence. Confidence is associated with a number of different things. So it includes enjoyment of the subject, assurance of being able to handle difficulties, lacking nervousness or worries about learning mathematics. So the questionnaires were distributed at 2 points during the year, and I've run this experiment in 2 years here, the 18-19 academic year and in 23-24. It's just a coincidence that the class size was exactly the same in both years at 160. So I distributed the questionnaire at the very start of the first lecture in both years, even before I introduced the module that they were about to start. So this was the second day of their undergraduate studies at 9:05 in the morning. I didn't want the undergraduate curriculum to influence their views, their beliefs. So this week 1 questionnaire was a snapshot of their beliefs at the very start of their degree, just having come from secondary level. And then I repeated the survey almost at the end of the teaching phase of the module in week 23. You can see the response rate is quite high at the start, and it has dropped off as we'd expect because the survey was conducted in class. So this really reflects the attendance at the lecture at that particular point in the year. And it was administered electronically through an electronic device. So let's look now at some of the results from the survey. So in all of these graphs that are coming up, the color scale is the same. the items had Likert responses. So the red is the strongly agree, and it works all the way down there to the strongly disagree in the blue. So just a snapshot of some of the data here. This is from 2018-19 at the start. This is for the whole class, and these are the items to do with value. And we see that at the beginning of their degree, there was strong agreement with the items associated with value, indicating that they already had a strong appreciation of the importance of mathematics to their studies and career. And this is important because we can expect the students then to engage willingly and actively with the subject. I think it was in this first item there that we had the strongest agreement in any of the items in the questionnaire that mathematics is useful in our life's work. So I think that's a 99% agreed or strongly agreed with that. If we look at the items related to struggle, again, for the whole class, and there's a strong acceptance that struggle is normal when working on mathematics. There, I think it's 90% agreed with that. And there's certainly acceptance of difficulties, even for good mathematicians. This feeling was stronger for the 23-24 class, whose secondary education had been disrupted during the COVID pandemic. And this is also an encouraging result, since if students understand that struggle is normal in the study of mathematics, even for good mathematicians, then they should be more tolerant and persistent in the face of difficulties. So here are the results for the same class for the items of growth. And these responses showed greater variation with a large proportion of neutral items, neutral responses there. So a little bit more uncertainty in the students' beliefs in these. However, overall, beliefs associated with a growth mindset were dominant across both years. And there was a strong rejection of the notion that nothing could be done for those who are deemed to be not good. That would be the middle pie chart there on the screen. The item said that nothing can be done to change someone's if they're not good at mathematics. But you can see that disagree or strongly disagree represents 88% with that. The characteristic of a growth mindset is very valuable at the beginning of university, as it should help perseverance when faced with challenges. So these charts show some of the responses regarding confidence. Generally, confidence was high regarding being able to handle difficulties and having less trouble with mathematics than other subjects and enjoying solving new problems. But there were some interesting differences in the 2 years under this category of confidence. So I've picked out two of the items there. That was finding mathematics frightening or finding mathematics confusing. And we see a little bit of a difference here. The 23-24 class, while mainly disagreeing that mathematics was frightening, they were less assured than their counterparts in the 18-19 year. And looking at the second item there, finding mathematics confusing. So in 18-19, most students disagreed with that. 55% disagreed, but 39% were neutral. However, in 23-24, there was a much higher agreement. About 20% said they find mathematics confusing, and only 41% disagreed with that. So we're maybe seeing here an impact of the pandemic on the students' beliefs about mathematics. The 23-24 class had their education disrupted. They were in secondary school, in fourth year of secondary school, when the pandemic was declared. And that substantial disruption at a crucial stage of their education may have influenced these feelings of confusion towards mathematics. Although it's important to note that those views were held by only a small minority in the class. We have looked a little bit at the gender differences, and it's hard to pick out very much in terms of gender differences, but possibly in these two items here, we see the greatest variation. Female students believe more strongly in the value of mathematics to their work compared to males, and female students seem to enjoy solving new problems more strongly. But gender differences in response to struggle were inconsistent, and any differences in male and female confidence were slight. So we didn't detect any results about confidence that might have been noticed at secondary level. It's sometimes said girls have lower confidence than boys in their mathematical ability, but we didn't detect that for these students. It's interesting to consider any change in beliefs over the course of the module, but this is difficult to analyze here because the response rate in week 23 was lower than at the start. And so you're getting a different group of students responding to the questionnaire. And it could be the better students who are persisting in terms of attendance. So it's hard to do a direct comparison of whoever's present at start and end. So to try and get around that, what I've done is broken down the responses according to it says their A-level grade. That's their secondary school leaving qualification. And since the responses seem to depend on previous grade, I've just extracted the grade A students. I think they were the largest subset, and looked at how their beliefs change over the course of the module. So here we see items with the greatest change over the course of the module, and the belief about value of mathematics in life's work has strengthened a lot by the end of the year. Under struggle, there was a notable change. Good mathematicians have difficulties, and their agreement with that statement has increased over the course of the module. So those are some of the main findings. Let me just sum up then. The students had a very high perception of value, and there was a strong acceptance that struggle is normal. And the growth mindsets seemed to dominate. Confidence was reasonably strong, but it depends on prior mathematical qualification. And the post-pandemic class seemed to be less assured than the class in 1819. But some things just for further consideration. The questionnaire responses were anonymous. So I suppose some future work would be to track individuals if we're allowed to do that. to investigate the change in individual beliefs over time. And then we could also investigate correlation between beliefs and performance or achievement in the assessments. It would be interesting if we could relate the beliefs then to the teaching and learning and assessment methods. And some results in the literature are interesting because I came across a paper that showed a decline across a range of categories, including confidence and persistence, mindset and interest, a decline in those beliefs over an academic year for first-year students studying calculus. And the researchers described this as a move away from expert-like orientations to mathematics. And they speculated that this was related to the nature of the first-year courses, with emphasis on procedural repetition and solution of low-level inauthentic problems. So that was an interesting study in the literature where they felt that the nature of the teaching actually contributed to a decline in beliefs in a way that we would not be happy with. So I think that there's some work there to investigate the influence of the teaching and learning and assessment methods. And then finally, I've been looking at engineering students, those are the students I work with. How would the results differ for students from other disciplines? Because for engineering, obviously mathematics is a crucial part of their studies. It's very influential across their modules, and we do expect them to be highly motivated, and we find that they generally do enjoy their mathematics and problem solving. So thank you very much for listening to me this afternoon or this morning, and I'll leave my email address there if anyone would like to reach out. I'd be keen to hear from you if you want to give feedback or have any suggestions how to develop this work. So thank you very much.
Thanks very much, Jonathan. That was really interesting, and we appreciate you getting up early and even putting on a tie for us.
Yes,
we've sat through a thunderstorm here this afternoon, and just having a quick look on my phone, we had hail the size of larger than a cricket ball in some parts of Brisbane, just 5 or 10 minutes away. So it's been a very muggy day here, but we're very appreciative that we've been able to finish off with your wonderful talk. So thanks again.
Thank you very much, Michael.
Well, we survived day one, or I survived day one, I guess, importantly. We will be back in this room tomorrow at 9 a.m. for our second key.